Have you ever felt like the world of AI, especially generative AI, is just moving incredibly fast?
Oh, absolutely. Warp speed feels about right sometimes.
Yeah. One minute it's, a fun chatbot. The next it's writing code, making images, maybe even drafting
So
proposals.
powerful stuff.
It is. But it can also feel like, well, a lot to keep up with, especially if you're trying to figure out how do we actually use this strategically in our business?
Exactly. And that's really why, for this deep dive, we're drawing from a fantastic source,
Yeah.
the official Google Cloud Generative AI Leader Certification Exam Study Guide.
Okay.
This isn't just, random articles. It's really a structured roadmap. It's designed to give you a solid grasp of the fundamentals, Google-specific tools, the techniques to get better results, and crucially, the business strategy side.
Right.
It's honestly perfect for anyone wanting a direct path to getting properly informed in this area.
That makes sense. So imagine you're, say, leading innovation at your company, and you're tasked with bringing in generative AI, but doing it smartly,
Mm.
ethically. Today, this deep dive is essentially that roadmap. We'll unpack what generative AI actually is. We'll look at Google Cloud's specific tools and how they can help your teams.
And how to make them work better.
Yes, those techniques to really tailor performance for your needs. And then, the big picture. The business strategies for making it successful and responsible. Think of it as your shortcut to what really matters.
Sounds good.
Okay, let's get into it. First things first. What exactly is generative AI? Most people have heard of artificial intelligence, AI, and machine learning, ML. Today, we're zeroing in on generative AI. That specific part of machine learning where the machines, well, they create things.
Yeah, they don't just analyze, they generate.
Yeah.
It's a real step change.
A lot of this is built on something called foundation models. These are huge AI models trained on just, well, staggering amounts of varied data.
And what's really revolutionary about these foundation models isn't just the size, it's how adaptable they are.
Yeah.
Like chameleons. They're not just for one specific task. They're more like a Swiss Army knife for AI. This flexibility means you can fine-tune them for all sorts of different uses, different industries.
Mm-hmm.
It really lowers the barrier for building complex AI.
And a common type people interact with, probably daily, is a large language model, an LLM.
Exactly. That's a type of foundation model focused specifically on human language, understanding it, generating it.
And this creative power, it isn't just text, right? These models can be multimodal.
That's a key point. Multimodal means they can handle and generate different types of data all at once. Think text, images, code, sometimes even audio or video.
Wow. And how does that translate into business value? What can they actually do?
Well, the study guide highlights 4 key functions. They can automate tasks that used to be manual, they can create genuinely new content, they can help discover information just when you need it, and they can summarize really complex stuff concisely.
Okay, automating, creating, discovering, summarizing. That's pretty powerful.
It really is.
And that creative power, it all stems from how machines learn from data, right? Machine learning.
At its core, yes, it's data-driven.
So maybe we can quickly cover the main learning approaches. There's supervised learning.
Right. Supervised learning is like teaching with examples that have answers. Think of training a spam filter. You show it lots of emails, clearly labeled spam or not spam.
Got it. Labeled data is the key.
Exactly. Then you have unsupervised learning. Here, the data is unlabeled.
So no answers provided.
Correct. The goal is for the model to find patterns or structures on its own. Imagine giving it a ton of customer reviews and asking it to find the main themes without telling it what themes to look for.
Interesting. Uncovering hidden patterns.
And the third one is reinforcement learning. This is about learning through trial and error, essentially.
Like training a game AI.
That's a great analogy.
Yeah.
The model takes an action, gets feedback, a reward or a penalty, and adjusts its strategy over time to maximize those rewards. It learns by doing and interacting.
Okay, supervised, unsupervised reinforcement. Got it.
But for any of these to work well, the data itself has to be good. High-quality data is everything.
Meaning what exactly? Accurate.
Accurate, yes, but also complete, consistent, relevant. And it needs to be accessible, easy to get to, usable in the right format. Garbage in, garbage out, as they say.
Right. And this whole process from getting data to having a working model, that's the ML lifecycle.
Precisely. It starts with data ingestion and preparation, getting the data, cleaning it up.
Yeah.
Then model training, building the actual model, followed by model deployment, making it available. And finally, model management, the ongoing monitoring, updating, maintaining.
It's quite a process.
It is. It requires discipline.
Now, zooming out a bit, the guide talks about the Gen AI landscape as a stack. Can you
Right.
walk us through those layers?
Sure. Think of it like building blocks. At the very top, which you interact with, is the Gen AI-powered application, your chatbot interface, your image generator tool, whatever it is.
Okay, the user-facing part.
Right below that is the agent. This is the smart software aiming to achieve a goal. It observes, it thinks, it acts using tools.
The brain doing the tasks.
Sort of, yeah. Then beneath the agent is the platform layer. This provides the connections, the APIs, data management, deployment tools. It links the models to the apps.
The plumbing, almost.
You could say that. Then you have the model layer itself. This is where the core algorithms live, the LLMs or other foundation models that learn the patterns.
The actual AI brain, then.
Yes, that's a better fit. And underpinning everything is the infrastructure. The hardware servers, GPUs, TPUs, and the software needed to run it all.
Hardware, software, model, platform, agent, application. That makes sense as a stack.
It helps visualize how everything connects. Now, looking at Google specifically, they talk about being an AI-first company. What that means in practice is they integrate these generative AI tools across their whole ecosystem.
So it's not just standalone products.
Not entirely, it's woven in. And this approach has some real benefits for businesses. First, you stay current. Google's constantly updating things, so you benefit from the latest advancements.
That's a big plus in such a fast-moving field.
Huge. Second, they emphasize security and responsible AI right from the start. It's built on an enterprise-grade foundation.
Crucial for businesses.
Absolutely. And third, they offer flexibility through an open approach. You often have choices. You're not totally locked in.
Okay, that's the high-level approach. But let's talk specifics.
Yeah.
What tools might someone, actually use day to day?
Good question. Let's start with personal productivity. At the core is Gemini, Google's main generative AI model family.
Right, I've heard of Gemini.
So there's the Gemini app, which is their chatbot. You can use it for writing help, summarizing, translating, even creating images.
Like a general assistant.
Exactly. And for businesses, there's Gemini Advanced, which adds more features and those important enterprise security protections.
Makes sense. And it integrates into their other tools.
Yes, that's Gemini for Google Workspace. So you might see it helping compose emails right in Gmail, or generating images directly within slides, or summarizing meeting notes in Google Meet.
Ah, so it pops up where you're already working.
Precisely. Saves time, smooths workflows. And for the more technical folks, there's Gemini for Google Cloud.
Okay, what does that do?
It acts as an AI assistant, specifically for Google Cloud tasks, helping write and debug code, manage cloud apps, analyze data in BigQuery, even giving advice on your security setup.
That sounds incredibly useful for cloud teams.
It really can be.
What about more specialized tools? You mentioned Notebooklm earlier.
Ah, yes, Notebooklm. This one's really interesting. Think of it as a personalized research assistant.
How does it work?
You upload your own documents, meeting notes, project plans, research papers, whatever. Notebooklm then uses AI to help you understand that specific information. It can summarize key points, answer your questions about the documents, generate ideas based only on your sources.
So it's grounded in my own material. It won't just pull random stuff from the web.
Exactly. It stays within the context of the documents you provide. It's like having an expert on your specific project files ready to chat.
That sounds potentially game-changing for research or project management.
It has huge potential, yeah.
Yeah. Okay, so those are tools for individuals or specific tasks. What about building and deploying these models at scale? Where did that happen?
That's where the platforms come in. The main one is Vertex AI.
Vertex AI.
It's Google Cloud's unified ML platform. It's designed for the whole lifecycle, building, training, deploying ML applications, including generative AI models like Gemini. You can tune them and deploy them there.
So it's the enterprise-grade workbench.
That's a good way to put it. Now, for quicker prototyping, maybe for individuals or small teams just exploring ideas, Google offers Google AI Studio. It's free, easy to use.
Ah, like a sandbox.
Sort of. But when you're ready for serious production-level apps that need to scale, that's when you move to Vertex AI Studio, which is part of the main Vertex AI platform.
Got it. Free studio for trying things out, Vertex AI for the real deal.
Exactly. And they also have Vertex AI Search, specifically for building powerful search and recommendation systems.
Okay. Now, what about applying this to customer interactions? That seems like a major area.
Huge. Google bundles tools for this into their customer engagement suite, built on their contact center as a service, or CCOS.
Okay, what's in that suite?
3 main components: conversational agents.
Right.
These are your AI-powered chatbots that can handle customer queries intelligently.
Right.
Then Agent Assist. This provides real-time help to your human agents. It can surface relevant knowledge base articles, suggest replies, automate notes, making human agents more effective.
So AI helping the humans.
Precisely. And third is conversational insights. This analyzes all those customer interactions calls, chats to pull out trends, sentiment, areas for improvement.
Understanding the voice of the customer at scale.
Exactly.
And you mentioned agents earlier. There's also Google Agent Space.
Yes. Agent Space lets you build and integrate custom agents, search agents, conversational agents directly into your company's internal websites or dashboards. The key thing is these agents can access and understand your internal data sources.
Ah, so internal-facing AI assistants.
Right. And when building these agents, there are common components. Extensions let them connect to external tools via APIs. Functions define specific actions they can perform. Data stores give them access to information. And plugins add new skills or integrations.
Lots of building blocks.
It's becoming quite modular. Maybe we should dig a bit deeper into what an AI agent actually is.
Yeah, that sounds good. It's a term used a lot.
So fundamentally, an agent is an application trying to achieve a goal. It does this by observing its environment, reasoning about it, and then acting using the tools it has available.
Observing, reasoning, acting.
Right. And it usually involves a reasoning loop. This is that cycle. Observe, interpret, reason, decide on an action, then act. Prompt engineering is often key here. Then there are the tools, the things it can use to interact, like accessing a database or sending an email. And finally, the model itself, the underlying AI like an LLM, which provides the intelligence.
Okay, reasoning loop, tools, model. Makes sense. Are there different types of agents?
Broadly, yes. You have deterministic agents. These follow predefined rules and paths, very predictable, good for structured tasks.
Like traditional automation.
Kind of, yeah. Then you have generative agents, which rely on natural language and LLMs, much more flexible, conversational, think chatbots.
Right.
But often, the most powerful are hybrid agents. They combine both deterministic logic and generative capabilities. They can follow rules when needed, but also handle ambiguity and converse naturally.
Best of both worlds.
Often, yes. And these agents can do all sorts of things. Customer service, boosting employee productivity, helping with creative work, generating code, analyzing data, even security tasks.
The potential applications seem vast.
They really are.
And all of this runs on the infrastructure, right? The hardware and software.
Absolutely. At the base is the core computing servers, powerful processors like GPUs and TPUs optimized for AI, and the software to manage it all.
But it's not just huge data centers anymore. There's AI on the edge.
That's increasingly important. AI on the edge means running AI models closer to where data is generated, or where actions are needed on devices, in factories, in cars.
Lower latency, less reliance on connectivity.
Exactly. Google provides tools for this, like Light Runtime, Literati for deploying models efficiently on edge devices. And they have specific models designed for this, like Gemini Nano, which is super efficient and designed to run right on smartphones or other devices.
Bringing AI directly onto the device. Cool.
Yeah.
Now, when you're using Vertex AI, what about the actual models? Do you have to build your own?
Not necessarily.
Right.
Vertex AI offers flexibility here. There's Model Garden, which is like a library or marketplace. You can find models from Google, from third-party providers, and even open source models.
So you can pick an existing one.
Often, yes. But if you need something very specific, tailored to your unique data or task, you can use Model Builder.
To train a custom model.
Right. You can either do it fully custom using standard ML frameworks if you have the expertise, or you can use AutoML. AutoML simplifies the process. It automates many of the steps involved in creating and training a model, requiring much less technical knowledge. It's great for teams that don't have deep AI expertise, but still need custom solutions.
That sounds really valuable for broader adoption.
It definitely lowers the barrier to entry. And just to round out the Google Cloud offerings, they have a whole suite of powerful APIs for specific data types.
Right.
Think of these as pre-built AI capabilities you can plug into your applications.
Okay, like what?
Well, there's speech-to-text and text-to-speech, pretty self-explanatory, translation API, and a specialized document translation API that keeps formatting.
Useful.
Very. Then there's Document AI API. This is powerful. It extracts structured data from documents like invoices or forms, automates processing, can even summarize them.
So taming the paper monster.
It's essentially, yeah. There's Cloud Vision API for analyzing images, tagging objects, detecting faces or landmarks, content moderation, visual search.
Seeing what's in pictures.
Right. And similarly, Cloud Video Intelligence API analyzes video content for things like recommendations or search. And the Natural Language API helps understand unstructured text sentiment analysis, classifying content, pulling out key entities like names or places.
Wow, a whole toolkit of AI senses.
That's a good way to think about it. And importantly, you can build applications using these APIs or the Gemini API for agents using standard developer tools on Google Cloud, or even using low-code, no-code platforms like AppScript or AppSheet.
Making it accessible even if you're not a hardcore programmer.
Exactly. Democratizing access is a big theme.
That's a really comprehensive overview of the tools. But, a practical question comes to mind. What if a company is already heavily invested in another cloud, like AWS or Azure? Are these Google tools compelling enough to consider integrating, or is it too much hassle?
That's a very real-world consideration, and yeah, any multi-cloud setup adds complexity. But Google does try to make it easier with open standards and APIs. Vertex AI aims to be a unifying platform.
But are the benefits worth the integration effort?
It depends on priorities. Google has deep AI research roots. Their models like Gemini are advancing rapidly, and they really emphasize enterprise security and responsible AI from the ground up. If those things, cutting-edge models, strong ethics, robust security, are top priorities, then yes, the benefits of integrating Google's Gen AI capabilities could definitely outweigh the integration effort, even if you have existing infrastructure elsewhere. It's often about augmenting, not necessarily replacing.
Okay, that makes sense. It's about specific strengths.
All right.
So now we get to the really interesting part, I think. You have these powerful models, these platforms. How do you actually get the best results? How do you make them do what you need?
Yes. This is where prompt engineering comes in. It's truly becoming both an art and a science, crafting the right inputs, the prompts, to get the best possible output from the AI.
Okay, so how do you get good at prompting?
Well, you can streamline things first. Think about reusing prompts, creating templates for common tasks so you don't reinvent the wheel.
Yeah.
Leveraging prompt chaining, which just means continuing the conversation. The AI remembers the context, so you can refine its answers through back and forth.
Like having a dialogue.
Exactly. In Gemini, you can use saved info, and they have a feature called Gem's personalized AI assistants you create within Gemini. You can give them specific instructions, templates. They become tailored helpers for your specific workflows.
Personalized AI assistants. Interesting.
Yeah, helps tailor the experience.
And what about different types of prompts?
There are several techniques. Zero shot is when you ask the model to do something without giving it any examples, just the instruction.
Okay.
One shot means you give it one example along with the instruction. Few shot means you give it, well, a few examples. This helps it understand the pattern you want.
Like mini training within the prompt?
Sort of, yeah. Then there's the role technique. You tell the model who to be, act as a marketing expert, or you are a senior software engineer. This influences its tone, style, focus.
Assigning a persona.
Exactly. And we already mentioned prompt chaining, that conversational refinement.
Got it. 0, 1, few shot, role chaining.
Those are key ones, but you can go deeper in guiding the model.
How so?
One crucial concept is grounding. This means making sure the AI's output is connected to reliable, verifiable information sources, not just making things up.
Avoiding hallucinations.
Precisely. And a powerful technique for grounding is retrieval augmented generation, or RAG.
RAG. Okay, how does that work?
It's a multi-step process. First, retrieval. The LLM intelligently searches and pulls relevant information from external sources, maybe your company's knowledge base, technical docs, whatever you connect it to.
Finds relevant facts.
Right. Second, augmentation. That retrieved information is then added into the prompt that's sent to the LLM.
So the prompt now includes the fact.
Exactly. Third, generation. The LLM processes this augmented prompt and generates its response, now based on that retrieved information.
Grounded in facts.
Correct. And optionally, there can be an iteration step where the model might refine the search if the first results weren't quite right. It's a powerful loop.
That sounds much more reliable for business use cases.
Definitely. It reduces the risk of incorrect information. And related to refining prompts, there are these advanced techniques, sometimes called reasoning loops.
Okay.
One is REACT, which stands for reason and act. It allows the LLM to not just think about a query, but also decide to take an action, like using a tool to look something up, and then integrate that information into its reasoning.
So it can use tools to help it think.
Kind of, yeah. Another is QAT, or chain of thought prompting. Here, you guide the model by showing it examples that include the steps of reasoning to reach an answer, not just the final answer itself.
Teaching it how to think through a problem.
Exactly. It encourages more logical, step-by-step processing. And then there's meta-prompting, which is pretty meta. This is where you prompt the AI to actually help you create or refine other prompts, like asking it Generate 5 different prompts I could use to ask for a marketing slogan.
Using AI to become a better prompt engineer.
Basically, yes.
Beyond the prompt itself, can you tweak the model's behavior directly?
You can, using what are called sampling parameters. Think of them like control knobs.
Okay, like what?
Token count. Tokens are chunks of text, roughly words. This affects the granularity. Temperature is a big one. It controls randomness or creativity.
Higher temperature means more creative, maybe riskier output.
Exactly. Lower temperature is more focused, predictable, maybe safer. Top is another way to control randomness, focusing on the most likely next words.
Temperature and top up for creativity control.
Right. Then you have safety settings to filter harmful content. And output length lets you set a maximum limit on how much text the model generates.
So you have quite a bit of control over the output style and safety.
You do. Tuning these parameters is key to getting the right kind of response for your specific need. Now, with all this amazing capability, we absolutely have to talk about the limitations. These models aren't magic.
Right. Important to be realistic. What are the main challenges?
Well, first is data dependency. Their performance is totally tied to the data they were trained on. If that data was biased, incomplete, or just plain wrong in places, the model inherits those flaws.
Garbage in, garbage out again.
Pretty much.
Yeah.
There's also the knowledge cutoff. Models only know things up to the point their training data ended. They won't know about very recent events.
So they can be out of date.
Correct. Bias is a huge concern. These models learn from vast amounts of text from the internet and other sources, which inevitably contains societal biases. The models can pick up and even amplify these biases.
That's a serious ethical concern.
Absolutely. Which leads directly to fairness. Ensuring models treat different groups equitably is critical for responsible AI.
Makes sense. What else? Hallucinations.
Yes, hallucinations. That's when the AI generates output that sounds plausible, but is factually incorrect or nonsensical. It essentially makes things up.
Confidently wrong.
Exactly. And finally, they can struggle with edge cases, unusual or rare situations that weren't well represented in the training data. This can expose weaknesses.
Okay. Data dependency, knowledge cutoff, bias, fairness, hallucinations, edge cases. That's a significant list.
It is. And understanding these is crucial for using AI responsibly.
So given those limitations, how do businesses manage the risks? How do you ensure quality and safety?
A key strategy is bringing humans in the loop, or HITL.
HITL, meaning people checking the AI's work.
Essentially, yes. Integrating human judgment directly into the workflow. It's vital in several areas. For sensitive applications like healthcare or finance, human oversight is non-negotiable.
High stakes.
Exactly. Same for high-risk decision-making. You want a human to review the AI's recommendation before acting on it. HITL is also used for pre-generation review, checking prompts or outputs before they go live, and post-generation review, where humans provide ongoing feedback to help the model improve.
Continuous improvement with human guidance.
Right. And it's crucial for content moderation, where human nuance is often needed to catch harmful content that algorithms might miss.
So humans remain essential for quality control and safety.
Absolutely.
Yeah.
HITL is a cornerstone of responsible AI deployment. And Google Cloud provides tools specifically for managing the model itself throughout its lifecycle to help with this.
Okay, like what kind of management tools?
For versioning, keeping track of different model versions, there's the Vertex AI Model Registry. You always know which version is running.
Important for tracking changes.
Critical. For performance tracking and drift monitoring, Vertex AI Model Monitoring helps you watch how the model is doing over time and alerts you if its accuracy starts to degrade.
Catching problems early.
Exactly. Data management for the features the model uses is handled by Vertex AI Feature Store. Storage for the models themselves is in Vertex AI Model Garden, and you can automate the whole ML workflow using Vertex AI pipelines.
So tools for the whole life cycle.
That's the goal. A unified platform.
Yeah.
And just quickly, 2 other terms worth defining here. Context window. This is basically how much text the model can remember or consider at one time during a conversation.
Like it's short-term memory.
Good analogy. If the conversation gets too long, it might forget the beginning. Understanding the context window limit helps you design interactions. And fine-tuning.
We touched on that. It's like specializing the model.
Exactly. Taking a big pre-trained model and training it a bit more on your specific data to make it an expert in your particular niche, legal contracts, medical notes, whatever. It boosts performance significantly for targeted tasks.
Makes a generalist into a specialist.
Precisely.
Okay, so we've covered the tech, the tools, the techniques. Now let's shift to the business side. If you're thinking about implementing Gen AI, what are the really crucial things to consider before you even start?
Great question. The guide stresses thinking about your needs first. Things like scale, how many users will this serve? Customization, how much does it need to be tailored to your specific domain? User interaction, how will people use it? Chat, API, embedded.
Practical questions.
Very. Also, privacy, how sensitive is the data involved?
Hmm.
Latency, how fast does it need to respond? And connectivity, where will it run? What's the network like?
Needs assessment. Makes
Yeah.
sense. What else?
Your resources. This is huge. People, do you have the AI skills in-house, or do you need to hire or train? Money, what's the budget for development, infrastructure, ongoing costs? Time, what are realistic timelines for the project?
People, money, time. The classic constraints.
Always. Getting clear on needs and resources up front is absolutely critical to avoid projects going off the rails.
So once you've assessed needs and resources, what does a good Gen AI strategy look like?
The ideal approach, according to the guide, combines top-down leadership vision with bottom-up employee ideas and feedback.
Both strategic direction and practical input.
Exactly. The key components of that strategy include a clear strategic focus. What business problem are you actually solving? It needs clear value, exploration, encouraging experiments, pilots, collaboration. Don't be afraid to try things.
Learn by doing.
Right. A fundamental commitment to responsible AI principles throughout. Proper resourcing, having a data strategy, using existing assets smartly, developing talent, measuring the impact. How does it actually move the needle on business goals? And finally, continuous improvement, learning from results, gathering feedback, iterating.
It sounds like a very integrated, ongoing process, not just a one-off project.
It has to be, especially in such a fast-changing field.
And you mentioned responsible AI there. That seems critical, alongside security.
Absolutely. They are highlighted as essential pillars. Responsible AI is about ensuring AI is used ethically and doesn't cause harm, considering fairness, transparency, accountability all through the life cycle.
From start to finish.
Yes. And secure AI is about protecting the AI systems themselves, the data they use, the intellectual property involved. Google Cloud offers features like secure infrastructure, identity and access management, IAM, security command center, monitoring tools to help build secure systems.
Security and ethics baked in from the start.
That's the goal. They shouldn't be afterthoughts. Okay, one last strategic piece. Choosing the right model for your specific use case. What factors should you weigh?
Good question. How do you pick?
Several key things. Modality, does the model handle the right types of data? Text, image, audio, video. Does it match your input and output needs?
Match the data type.
Right. Context window, we talked about this. How much memory does it need versus the computational cost? There's a trade-off.
Balancing concurrence and cost.
Exactly. Performance accuracy, speed, efficiency. Again, there are trade-offs, often with cost. How good does it need to be versus how much can you spend?
The performance cost balance.
Critical. And finally, availability and reliability. Is the model consistently up and running? What are the service level agreements? You need something dependable for business use.
Modality, context window, performance, reliability, key selection criteria.
Definitely. You need to align the model's capabilities with the specific demands of your application.
Wow. And just like that, we've really covered a lot of ground on generative AI.
We certainly have.
We started with the fundamentals, what it is, how it learns. Then we dove into Google Cloud's toolkit, the Gemini variations, Vertex AI, those specialized APIs.
The building blocks.
Then the crucial techniques, prompt engineering, RAG, tuning parameters to actually get good results.
Making it work smarter.
Right. And finally, tying it all together with the business strategy, responsible AI, and how to choose the right model.
It's a comprehensive view based on that certification guide. And I think the key takeaway is that being a generative AI leader isn't just about knowing the tech specs. It's about understanding how to apply it effectively, ethically, strategically within your context.
Yeah, the leader part implies strategy and responsibility.
Exactly. And given how fast things change, that commitment to responsible principles and just continuous learning is absolutely essential.
Well said. So we've seen how powerful generative AI can be when you understand it and apply it properly. Here's a final thought for you, the listener. How might you use a tool like Notebooklm, which we discussed, the one that learns from your documents, to build your own personalized knowledge base on some complex topic you need to master? Imagine turning all that dense information into insights tailored just for your goals.
That's a fascinating application.
What stands out to you as the most potentially impactful area for generative AI in your world, based on everything we've unpacked today?